Hello, this is a video on factors that affect the rate of dissolving or making a solution. This is not, so this is asking how fast in time does it take to dissolve something. It's not how much, as in how much you can dissolve in a given solvent. We've already talked about that. So there are actually four, and I lump two of them together, factors. One, of course, is temperature, which we had talked about before in the temperature effects on solubility video. That's talking about how much solute you can given the amount of solvent. This is how fast it dissolves. Well, it's going to dissolve faster because the solute particles and the solvent particles have more energy, so they're moving faster. But also, it's a function of how much empty space. Okay, but in general, it's the fact that those base particles want to get away from each other to dissolve, and since they're moving with more energy, they're doing it faster. Now, for surface area in stirring, that's all about, and I lump them together because most people don't. Surface area is usually increasing surface area causes an increase in speed of dissolving, and stirring also causes it. Stirring is not a function of temperature. It's kind of like changing the rate of reactions in kinetics. This is almost identical, and it's all about getting solute particles near the solvent particles, because dissolve, the solvent particles must surround the solute particles or must detach the particles of the solute from the base particle, from the rest of the solute particles. So if they're exposed to each other more, i.e., using kinetic words, that the solute particles are near the solvent particles, they will dissolve more quickly. And that's what happens with increasing surface area and increasing stirring. It's simply that more solute particles are near solvent particles, so they can dissolve. And then the last one, that's I believe two different characteristics that I lump together. And the last one's a little bit harder to explain. It's the actual concentration of the solution before you try to dissolve it. So here, I kind of think of it as like suitcase, going on a vacation or a series of suitcases. The closer the solution's concentration to saturated, i.e., the closer it is to the saturation point. Remember, saturation point is no more empty spaces. The closer the starting solution is to the saturation point, the longer it takes to dissolve. Simply because either there is very few empty space left, so it takes a long time to find that empty space, or the other way of saying it is, there is very few base unit solvents or particles of the solvent left to dissolve it. So it takes a long time for them to get there. And if you have a solution that isn't near its saturation point, there's a lot of solvent particles available, and there's a lot of empty space. So it takes less time to put those base solute particles into those empty spaces. Close to saturation, it takes a long time to find them because there's very few left. So therefore, as you get closer to the saturation point, the rate of dissolving gets slower and slower and slower. Okay, and those are the four characteristics or factors that affect the rate of dissolving, and it's all about solvent particles in empty spaces, as all solutions are.